Sets. It can be denoted by either in a roster form. That means once the braces are there, all the elements has to be listed there, separated by commas. No matter how many number of elements are there, it all has to be listed. Second one is by set builder form. Here there is no need to list all the elements, only the definition of the set can be listed. Let's say a set A is defined as having element x, where x is a, now comes the definition of x. It can be like all natural numbers up to 10, or like all integers up to a certain point, whatever definition you put, that comes here. Now we will see the broad types of sets. Sets can be broadly classified into three. One is empty set. Empty set means there is no elements in it. It is a null set, often denoted by this symbol. And the second one is finite set. That means it is only having finite number of elements. And the third one is infinite set. That means having endless number of elements. Example, all the numbers. It can go on to infinity. Then the other terminologies you need to know is equal set. That means if set A has all the elements of set B, and also set B has all the elements of set A, that means set A and B are equal sets. It is not like only set A has all the elements of set B, but B doesn't have all the elements of set A. That doesn't satisfy the condition. They both has to have all the elements in the other set. Then comes the subset. Subset is a terminology. Let's say set X defines names of all the people in your city. That automatically includes all the family members in your house, that also. And set Y defines names of all the people in your house. That means set Y has already come in set X. So set Y is a subset of X. Then we all know that the empty set is subset of every set. This is a rule you need to remember. This you will need in simplifying some set equations. And another thing is every set is a subset of itself. That means set X is a subset of X itself, and set Y is a subset of Y itself. Now comes the intervals as subsets. Intervals, let's say we are going to give a set from alphabetical order, small letter A to Z. A to Z is equal to X, and X is defined as alphabets from B to Y. Why B to Y? Because we have used the normal bracket. That means it is an open interval. Open interval means whatever the limit I have defined, they are not part of the sets. That means A is not part of the set and Z is not part of the set. Everything in between becomes part of the set. That means from B to Y. Then comes the closed interval set. The difference here is the square brackets. Once the square brackets is means both the limits are also part of the intervals. That means A comma Z is equal to X means X is alphabets from A to Z, not from B to Y. It can be open at one and close at other end also. Like A can be excluded and Z has to be included, or A has to be included and Z has to be excluded. That can also be possible if you use the symbols carefully. Then comes the power set. If A is equal to a set having elements 1 and 2, then set of all subsets of A is equal to element 1 and element 2 and both element 1 comma 2 and a null set or empty set. The power set of A is equal to 4. It is just the number of all set of all subsets 1, 2, 3 and 4. Or the number of power set NPA is defined by the formula 2 power m, where m is the number of elements in set A. let's say instead of 1 2 it's having 1 2 3, that means 2 power cube, 2 into 2 4 and 4 into 2 8, that will be the power set of A. Then comes the universal set. In any given context, whatever the like a set, subset and everything that we extract from a base set, that is called as the universal set. In all population studies, the universal set is all the people in the world. Hope you get the idea now. Let's say if you are talking about colors, like what are the possible colors, then the entire spectrum of colors in the visible spectrum becomes the universal set. Now comes the Venn diagram. Venn diagram is nothing but visualization of the relation between sets. Here A is a set and U is the universal set. A is part of that. Instead of words, this is just a visual representation. Operation of sets. First is union of sets. A union B is equal to, as in the shaded in red, it contains all the elements in A and B put together. Now intersection of sets means, let's say A intersection B, only those areas that share a common portion between A and B becomes the A intersection of sets. Only the elements present in this area will become the answer for A intersection of B. Then comes the difference of sets, that is A minus B. It is like once A minus B means, even though there is a small portion of A comes within the B, that also gets clipped off. Any portion of A without any like a shadow of B becomes the answer for A minus B. That means, as in the shaded portion, whatever the elements falls in this area becomes the answer for A minus B. Then comes the complement of set. Complement is often defined as a, let's say if you are talking about set A, then complements is defined as A dash. A dash is nothing but the universal set minus set A, that becomes the A dash. If somebody is going asking what is the complement of A, whatever is the universal set minus set A and whatever is the shaded portion here, that elements, those elements that fall in this shaded portion becomes A dash, and that is called the complement of set A.